Good afternoon, everyone.
Good afternoon, ma'am.
Yeah, good afternoon. Just give me 1 or 2 minutes. I'll start the class. Yeah. So can you hear me?
Yes, ma'am.
Okay. So as we have discussed today, different things like the introduction related to neural networks. Okay. And then what is perceptron? So just I've given you just introduction related to that. So again, the next topic is perceptron. Okay. So what is perceptron here? First neural network learning model in the 1960s. It is simple and limited. It is single layer model and the basic concepts are similar to multi-layer models. So this is a good learning tool still used in current applications. So now still we are using perceptron learning algorithm. So here we will be using single layer perceptron, multi-layer perceptron. We will be having two. Okay. At the particular situation, we will be using either single layer or multi-layer. So morely we will be using multi-layer only. Okay. So here, what is perceptron? It is a single layer neural network. Okay. And a perceptron takes a vector of real valued inputs, calculates a linear combination of these inputs, then outputs a 1 if the result is greater than some threshold and -1 otherwise. So first of all, perceptron is nothing but it is one of the neuron. It is a particular neuron, and it is type of artificial neural network system. And here it is a basic unit in neural networks, and combination of many perceptrons will form structure of neural network, and it is also called as linear classifier. Okay, so linear classifier is nothing but it tries to classify something, some output. Okay, so here what is it? A perceptron take the vector of real valued inputs, means it will be taking different real value inputs. That is nothing but x1 is equal to some value, x2 is equal to some value, x3 is equal to some value, so likewise. Okay, so I'll show you the example also. So here this is the perceptron node, threshold logic unit. So x1, x2, xn, so on, x1, x2, so on, xn are different types of neurons, are different types of perceptrons, or these are also called as nodes, which we will be using as the input values. So whatever the data set which is there, మన దగ్గర ఏదైతే data set ఉందో, so for that data set, those are given as the input. So those as given as x1, x2, so on. How many attributes which are there, those are given as x1, x2, x3, so on, xn. Okay, in our table if you are having 6 attributes, that is name, hall ticket number, marks, mobile number, result. So likewise you are having different attributes, so these attributes are given as x1, x2, x3 and so on as the input. Okay, now for this what we will do, we will give different types of weights. Why we are giving weights here? Weights are given to adjust the input values. As it is, if we give the input values, we will not get the accurate result. So for this purpose, what we are doing, we are giving different types of weights. So how the weights are given? Weights are given according to the input values. If a particular attribute is having the higher or highest what you say, danki preference, if we are having the highest preference to that particular attribute, so what we will do, we will give some more high weight to that particular attribute. Okay, so whenever the input values with different attributes, the input values are given, so in that input values some different attributes will have the highest preference. So those, for those input values, the weights will be given the highest value here. Okay, so here learn weights such that an objective function is maximized. What objective function should we use? What learning algorithm should we use? So what is that objective function we have to use? So here we will be using one linear combination. Okay, so what it is, the linear combination is nothing but, I'll show you. So here you can see on the screen, the linear function is nothing but w0 plus w1 x1 plus so on w1 xn. So what are these? These are nothing but input values with different weights. So in this way we will be generating one linear combination. Okay, linear combination is nothing but linear classifier. Some equation, some function is generated with input values and weights. Okay, So here, if the threshold is 0, whenever the linear combination of all the inputs is greater than 0, then it is output as 1. So ఇప్పుడు మనకి ఏమవుతుంది, whatever the function which we are having, if it is greater than 0, the value, if we are evaluating this function and we are getting some value, if the value is greater than 0, that is nothing but the output is 1. Otherwise, if we are getting less than 0, the output is nothing but -1. Okay, so what is happening here, there will be positive values and negative values. Okay, so 1 is nothing but positive value, -1 is nothing but negative value. Okay, so in the plane, whatever the values which are there, that will be plotted negative side and positive side. Okay, so with one example you can know what will happen over there. Okay, so here where each wi is a real valued constant or weight that determines the contribution of input xi to the perceptron output. So weight will give or determine something based upon the input value. Okay, so here weight will contribute something to the input value to get the output value. And here minus W0 is a threshold that the weighted combination of inputs, this must surpass in order for the perceptron to output as 1. So if we want the positive value, what we have to do, we have to give one constant value. The constant value is some threshold. Example enti anante bank salary undi. Okay, so bank salary lo the highest salary will be 1 lakh. So what is the threshold there? 1 lakh. So likewise, what is happening, the weights will have some threshold. So according to that threshold, the output will be triggered. Based upon the threshold and the linear combination with the different weights and input values, the output will be triggered. So this is nothing but perceptron. So here the perceptron takes the vector of real values input and calculates the linear combination of different inputs. So what is happening? It creates different linear equations. Okay, so this is linear equation, what you are seeing here. So this is linear equation. So here in previous classes we have seen one chess problem. Okay, the same example I'll explain you, or some more example. So if we want, we have to train the model here in such a way that how to improve the accuracy. So what we are doing here, we are giving the weights. So how the weights are given, so I'll show you one example here. So there is one canal. Okay, oka canal undi. మనం ఏం చేస్తున్నాము, it is somewhat, the distance is somewhat 5 feet. Okay, so we want to cross the canal here. So what we will do, first we will start here, from here we will start and we will cross the canal. So what will happen, we cannot, we will fall in that. Okay, so next what we will do, we will take one step forward from here and we will go. So again also we will not get, we can't reach. Again what we will do, from here we will move forward. Okay, and so with that what will happen, we will reach the canal. So what is happening here, we are just improving the accuracy in the result. How we are giving the accuracy, how we are generating the accuracy, so with adjusting the weights. Okay, so manamu first time try చేసాము, రీచ్ అవ్వలేదు. ఓకే, సో ఏం చేస్తాము, ఒక స్టెప్ స్మాల్గా వేస్తాము, నెక్స్ట్ టైం ఏం చేస్తాం, ఇంకొంచెం పెద్దగా వేస్తాము. సో ఇట్లా మనము అడ్జస్ట్ చేసుకుంటూ మన ఏదైతే డెస్టినేషన్ ఉందో రీచ్ అయినాం. సో లైక్ వైజ్ what we are doing when linear combination is generated, when we are implementing that linear combination to the model, with the help of input values, it will be adjusted according to the input values and we will get the output here. Okay, so this is nothing but perceptron. You can see here the constant is used, so we will be using some constant to improve our accuracy. Okay, so these are the different input values. With that input values we will be giving one constant weight value and different weight values here that will be summed. Okay, and that will be stepped to get the output here. Step function is used to get the output here. So this is perceptron. So here you can see this is one example. In the below, so here you can see x1, x2. x1, x2 are two input values. So input values are having 0.8, 0.3, 0.4, 0.1. So these are the two input values we are having under data set ankondide. So what is your target function? For your first row, the target function is 1. And for second row, the target function is 0. So is it true or false? That we have to see by generating the neural network problem here by using perceptrons. Okay, so first 0.4, point minus 2. So these are the two weights we are assuming here. Okay, now what will happen? We will get 0.1. So you can see here 0.4 and minus 2 minus 0.2. These are the two weights, W1 and W2. These are the two weights which we have assumed. Okay, and 0.8 and 0.3 are the already we are having the values, first row values. So we have given x1 and x2 value. With that we are giving two weight values. 0.1 is the threshold value. So we have taken some threshold value. Okay, so 0.1. So what is happening here? We have got, for first row we have got 0.26. 0.26 అనేది greater or smaller? 0.26 is correct or not? Guys, I'm asking to you. I'm calculating the weights here. I'm calculating the output here. So my input values are minus 0.8 and 0.3, x1 value, x2 value. With that I'm giving weight values 0.4 and minus 0.2 value. What has happened? I have got 0.26. Whether it is true or false, whether my target value and predicted value is correct or not. Respond something. Zero 0.1 పెద్దదా, 0.26 పెద్దదా? Which one is bigger? 0.1 or 0.26? Can you hear me?
Yes, ma'am.
So which one is bigger? 0.26.
Yes, ma'am.
So here 0.26 is bigger. Okay, so it is greater than 1, 0. Okay, so it is greater than 1 here. So what is happening is z is equal to 1 we are getting. Okay, so we are getting positive value. So positive value represents as 1. What is our target value? It is 1. So here also we are getting as 1. Okay, output is triggered as 1 as it is greater than 0. Okay, so what will happen? We will get 1. In the previous slide I have told you, if it is greater than 0, we will get 1 here. If it is less than 0, we will get minus 1 here. Okay, so what is happening? We are getting greater than 0. So whatever the target value which we are having 1, that is equal to our prediction value. So see the second training instance. What is the second training instance? 0.4 and 0.1. So we are giving 0.4 and 0.1. So what we are getting? 0.14. So here we are getting z is equal to 1. As it is greater than 0, predicted value is 1, but our target value is 0. Okay. So what is happening here? Whatever the weights which has given to the second instance, it is not adjusting. So what we will do? Again, we will adjust the values. So here the example is there. So here you can see how it has done. We have used epoch is equal to 1. So epoch is 1 ante enti ante 1 iteration. Okay, iteration చేసాము. దాని ఎంత వచ్చింది? 0.13 వచ్చింది. సో మనం ఏం చేయాలి? We have to less the error rate. So error rate ni less చేయడానికి again what we are doing epoch is equal to 5. Epoch is equal to 5 is nothing but 5 iterations. Whatever the iteration which is there, that will be again iterated, repeated. So here when we are giving the weight values and input values, the weights are not adjusted to the input values. Okay, so what we will do, again we will change it and we will repeat this process. Repeat this process for all the instances which are there in the data set. Okay, so first instance ki the weights are adjusted, but for the second instance the weights are not adjusted here. So here our threshold value is 0.1. Okay, so what we have to do here, if the value is greater than that, then we will get z is equal to 1. Greater than 0, then we will get z is equal to 1. If the value is less than 0, ante negative lo ochindi ankondi, then what will happen? We will get z is equal to 0 here. But we are getting z is equal to 1. So this should not be there. So what we have to do, we will repeat this process. How we will repeat this process? By adjusting the weights. Just only this is example. Don't keep in mind all these things. Okay. So I'm telling you how we are going to adjust the weights here. So this is about perceptron. When we are giving the input values, according to the input values, we have to adjust the weights. Depending on the attributes, we have to adjust the weights here. Then only we will get the accurate result. Okay. So this is done by using delta WI. So this is nothing but perceptron training rule. So here you can see delta. So what we have got some error. Okay, so to reduce this error, what we are doing, we are using delta WI. Delta WI is nothing but it is the perceptron training rule which is used to decrease the error rate Okay, so the formula is T minus Z into C into Xi. Okay, so here delta Wi is nothing but change in value, that is variation in weights. We have to change the weights here. That is equal to T is nothing but target value. Whatever the target value in our table we are having is 1 and 0. That is the target value. We will be replacing with that value, minus Z is nothing but our output value into C is nothing but learning rate. ఇంతకుముందు నేను చెప్పాను learning rate అంటే ఏంటి, step by step we will increase that. Okay, into Xi. Xi is nothing but your input value. Okay, so this is the formula to reduce your error rate. So this is nothing but perceptron training rule. So when we get a wrong output, then than the expected target value, then we go for revision. Okay, so we use delta Wi whenever we get any error in output. Okay, so we will revise again. That is why we will go back, we revise the error, we will error is decreased by changing the weights. Okay, for that we will be using a delta Wi formula. Okay, so this is nothing but perceptron training rule. So this is perceptron rule learning, where Wi is the weight here from input I to perceptron node, and C is the learning rate. See what it will do, it will learn again and again the error rate. And T is nothing but the target for the current instance. Manaki data set lo already target value untundi, that is T. Z is the current output. ఒకసారి మనం ఎగ్జిక్యూట్ చేసినాక మనకి ఏదైతే అవుట్పుట్ వస్తుందో ఆ అవుట్పుట్ వాల్యూ, అండ్ Xi is the ith input. So first instance, Xi is nothing but the first instance. So here we will be using least perturbation principle. So what is happening here, only change the weight if there is an error. సో ఇంతకుముందు మనకి ఎర్రర్ వచ్చింది, మనం ఏం చేయాలి, అప్పుడు వెయిట్స్ ని చేంజ్ చేయాలి. అక్కడ ఎంత ఇచ్చాం మనం ఇంతకుముందు, -0.2 ఇచ్చాం. సో ఇన్స్టెడ్ ఆఫ్ గివింగ్ -0.2 వీ కెన్ ఇంక్రీజ్ దట్ -0.4 ఇంక్రీజ్ చేసి ఎట్లా అవుతుంది, ఏమొస్తుంది, అప్పుడు మనకి అవుట్పుట్ కరెక్ట్ వస్తుందా లేదా, అగైన్ వీ హ్యావ్ టు చెక్. ఇఫ్ again also we are not getting the value, what we have to do, we have to repeat this process. So here small c, rather than changing the weight, sufficient to make the current pattern correct. Scale by xi. So this is the perturbation principle which we will be using to decrease the error by using perceptron rule learning. First, what we have to do, we have to create a perceptron node with n inputs. Iteratively apply a pattern from the training set and apply the perceptron rule. Perceptron rule and so error rate కనుక్కోవడానికి just we will give the input value, okay, and give the weights, and we will execute that. We will get some output. Okay, each iteration through the training set is an epoch. Epoch is nothing but one iteration. So మనము 5 iterations చేస్తే epoch is equal to 5. అంటే నెట్వర్క్ ని మనం 5 times repeat చేసాము. Epoch is nothing but the total number of iterations, how many times we have did. That is epoch. Continue the training until total training set errors ceases to improve. Until we get a less error rate, we'll repeat this process. Perceptron convergence theorem guarantees to find this solution in finite time with the solution. So at last we will get the best fit by applying this perceptron rule learning. So here we need to adjust the threshold value. So every time the threshold value will not be same. According to the data set, we will use a threshold value. Okay. So do we need to adjust the theta? Yes, we have to adjust the theta is nothing but the threshold value. Okay. So this is about perceptrons. Next is representational power of perceptrons. So here the perceptron can be viewed as representing a hyperplane decision surface in the n-dimensional space of instances. So how many instances are there? Those many instances we can represent it as in a hyperplane. So here we are having two attributes, two instances, x1 and x2. Okay. So here you can see in figure a set of training examples and the decision surface of a perceptron that classifies them correctly. So what is happening here? Whatever the data which is there, that is classified correctly here. Why? Because we are getting the correct hyperplane. Straight line of correct వచ్చిndi. Annitni separate chesi. Chudandi, you can see here. All places are on one side. All dots are on one side. That is nothing but the data is linearly separable. So here you can see these are one type of data and these are one type of data. So this is your hyperplane. This has been linearly separated the values. Okay, whatever the values which are there, that has been linearly separated here. Okay, so this is correctly classified. This is called as linearly separable. Non-linear separable. This is non-linear. Why? Because you can see here, whatever the data which is there, that is not separated correctly. A set of training examples that is not linearly separated. X1 and X2 are the perceptron inputs. Positive examples are indicated by plus, negative by minus sign. If you want to classify this, how we are going to classify this? We have to classify like this. So this can't be done. So why? Because we are not getting any hyperplane here. So that's why it is called as non-linearly separable. Okay. So here the perceptron outputs as 1 for instances lying on one side of the plane and outputs as -1 for other instances. So as I have told you, for your linear combination, if you are getting greater than 0, it is classified as 1. For your linear combination, if you are getting less than 0, it is classified as -1. Okay. So here a single perceptron can be used to represent many Boolean functions. Here we are using AND function. So this is your data set which you are having. So here AND function is used, A and B. 0 and 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. I think you know this. This is called as truth table. So if we are applying this particular data to our network, so what will happen? Is it true or false? So in this way, we will be representing all the Boolean functions here, AND, OR, XOR, all these things. Okay. So here you are having two variables A and B as input. Okay. And you are giving the weights as 0.6 and 0.6. So what is your first instance? 0 and 0. First row emundi values, A value 0 on the B value 0. So you are 0. So what will happen? 0 into 0.0 plus 0 into 0, 0 is 0. For predicted one and all is correct. And in this instance, 0 and b is equal to 1. A is equal to 0 and b is equal to 1. We are giving the second instance. 0 into 0.6 is 0. 1 into 0.6 is 0.6. So we are getting 0.6. So this is not greater than the threshold. So what is the threshold? Threshold is 1 here. So as it is not greater than 1, so the output will be 0 here. Okay, threshold ఒకవేళ less than అయితే 1 వస్తుంది, greater than అయితే 0 వస్తుంది. ఓకే, సారీ, greater than అయితే 1 వస్తుంది, less than అయితే 0 వస్తుంది. సో మన threshold ఏంటి ఇక్కడ? theta is equal to 1 we are using. Okay, so the threshold, if it exceeds the threshold value, so greater than something 1 వచ్చింది అనుకో, ఇక్కడ 1 కంటే ఎక్కువ వచ్చింది అనుకోండి, సో అవుట్పుట్ అనేది 1 వస్తుంది మనకి. గ్రేటర్ దాన్ ఉంటే అవుట్పుట్ ఈజ్ ఈక్వల్ టు 1. లెస్ దాన్ వచ్చింది అనుకో, అవుట్పుట్ అనేది మనకి 0 ఉంటుంది. థ్రెషోల్డ్ కంటే అవుట్పుట్ ఒకవేళ మనకి లెస్ దాన్ వస్తే 0 ఉంటుంది. సో ఇక్కడ చూడండి, మీకు ఫస్ట్ ఇన్స్టాన్స్ ఇచ్చినప్పుడు వాల్యూ 0 వచ్చింది. ఓకే, so 0 less than 1 or 0 greater than 1? 0 is less than 1. So what is our output? For instance, that is 0. When we are giving the input as a is equal to 0 and b is equal to 0, we are giving the value 0. So it is correct. This is correct. In the same way, check for second one. Second is 0 and 1. So here we are getting 0.6. 0.6 is less than 1. So the output will be 0 here. So this is also correct. Predicted one and expected one is correct. In the same way, if a is equal to 1 and b is equal to 0, we will get the value as 0.6. This is also less than 0. Sorry, less than 1. So if it is less than 1, the output will be 0. So it is also correct. Next is a is equal to 1 and b is equal to 1. So we are getting 1.2. It is greater than 1. Okay, so the output will be 1 here. So the expected one and predicted one both are same. So whatever the input which are there and the output value which we are getting for our data set, it is the network is showing or getting the result accurate. So the whatever the network generated or linear combination which we have generated, that is correct. Okay. So the role of learning rate is to moderate the degree to which weights are changed at each step. It is usually set to some small value, 0.1. So the learning weight every time it will be set to 0.1. Small value, 1, 0.1. So likewise, and is sometimes made to decay as the number of weight turning to iterations increases. Okay, so if the iterations will going on increasing, what will happen? The network will be increased. ఎందుకంటే hidden layer లో మనకి ఎక్కువ networks iterations ఉన్నాయనుకోండి, that is nothing but it will take more memory. So likewise, okay. So we have to see there should be minimum iterations in our network. So here the drawback of the perceptron rules are that it finds a successful weight vector that the many examples are linearly separable. It can fail to converge if the examples are not linearly separable. So this is not used for linearly separable model. This is only used for linearly separable. Okay, so this is the main drawback of perceptron. So you can see here, this is the example. Some data is there that we have plotted in a plane. So we are separating the data here. So this is linearly separable in this case. But if you see here, the new data is there on both the sides. Okay, positive value and negative value and positive. So what we are doing here, we are separating it. Then there is noise. Okay, if there is more noise, what will happen? We will be separating in this way. So this is not correct. So there will be limited functionality, limited data will be grouped. Okay, whatever the data which is there, that will be limitedly grouped here. Okay. So for handling that, we will be using multi-layer perceptrons. Okay. So this is about perceptron and how we are representing the perceptron and what is the perceptron training rule. Perceptron training rule is nothing but data WI, that is error rate. We have to decrease the error rate here by changing the weights or adjusting the weights. Okay, so that is the perceptron training rule. Next is gradient descent and delta rule. So if you see this figure, so what is happening here? Wait a minute. So if you see here, there is one mountain. Okay. So just I want to tell you about the gradient, descent and delta rule. So what is happening? I want to climb this. దీని ఎక్కాలి అనుకుంటున్నా. సో నేను ఏం చేస్తాను? So from here to So if you see here, so there is a mountain here. So what I am doing, I am starting here. Okay, individual start చేస్తాను mountain ఎక్కడానికి. So from here I'll start. Okay. So here, from here to some extent, what will happen? I'll use small steps, some large steps, some gems. So likewise. So I'll be using different ways to climb. And after some time, what will happen? It is a peak stage. Okay. So what I'll do? I'll use some more. No, I'll not jump, but I'll use small steps and some large steps. Again, from some place to the high peak stage, what I'll do? I'll use only small steps to reach the point. Okay. So నేను కొంచెం దూరం వెళ్ళడానికి నేను స్మాల్ బిగ్ అండ్ జంప్స్ యూజ్ చేసుకుంటూ కొంచెం దూరం ట్రావెల్ చేశాను. కొంచెం దూరం అయిపోయాక కొంచెం దూరం వెళ్ళడానికి స్మాల్ స్టెప్స్ వేసాను, బిగ్ స్టెప్స్ కూడా వేసాను. మళ్ళీ కొంచెం దూరం వెళ్ళిపోయాక అక్కడ స్మాల్ స్టెప్స్, బిగ్ స్టెప్స్, ఐ మీన్ హై జంప్స్ అవన్నీ వీల్ కావు. So what I'll do? I'll use only small steps to climb. Okay. So now what has happened here? I'm using some gradient descent rule according to the situation. Okay. So we will, if we want to reach the point, so the gradient ranging from x0 to x1 is much longer than the one reaching from x3 to x4. So this is because the steepness slope of the hill which determines the length of the vector is less. Okay. So this is nothing but big learning rate and small learning rate. So this is nothing but learning rate. So what is happening here? The system has learned something. Okay. So if you see in the big learning rate, the range is small steps చేశాను, మరి తర్వాత బిగ్ స్టెప్స్ చేశాను, మళ్ళీ జంప్స్ చేశాను. సో దిస్ ఇస్ నాట్ పాసిబుల్. సో వాట్ ఐ హ్యావ్ టు డూ హియర్ ఇస్ స్మాల్ లెర్నింగ్ రేట్ షుడ్ బి యూజ్. స్మాల్ లెర్నింగ్ రేట్ యూజ్ చేసి ఏమవుతుంది అంటే కొంచెం ఎర్రర్ రేట్ని మనం తక్కువ చేసామనుకో ఏమవుతుంది, మనకి ఇంప్రూవ్మెంట్ ఎక్కువ ఉంటుంది. సో దట్స్ వై వీ విల్ బి యూజింగ్ స్మాల్ లెర్నింగ్ రేట్. ఓకే. So here deriving a gradient descent learning algorithm, that is nothing but goal is to decrease the overall error. So we have to decrease the overall error each time the weight is changed. Different times we will be using weights at different places. Okay, when we are using that weight, we have to decrease the error. So this is our objective. So here total sum squared error, one possible objective function, that is E. E is nothing but your error rate. That is nothing but summation of Ti minus Zi. So Ti your target value, Zi is your observed value, whole square. So when you are getting negative value, that will be whole square, then you will get positive value. So here we will be derivating that. Take a weight change algorithm such that derivative of E by derivative of weight. E is nothing but error rate, W is nothing but your weight, is negative. If a formula can be found, then we have a gradient descent learning algorithm. So that is nothing but delta rule, is the variant of the perceptron rule, which gives a gradient descent learning algorithm with perceptron rules. So delta Wi is used to decrease the error rate here. So target value is 0, we have to get 0. If we got error and we have to reduce it, we will be using E. E is nothing but error rate. Okay. So that is this value Ti minus Zi whole square value. Okay. And when we are changing the values, we will be using the delta value. This is the total error rate, that is delta Wi, that is equal to C into T minus net of Xi. So C your learning rate అనేది మీరు 0.5, 0.1. So likewise according to the values you will be assigning it. T is your target value minus Net is nothing but your weight value into xi value. Xi is your input values. So what is your learning rate? If learning rate is too large, you can jump around the global minimum. If too small, will get to minimum, but will take a longer time. Can decrease the learning rate over time to give higher speed and still attain the global minimum. So what you have to do? It should be small. The learning rate should be, the value should be small. Then only we can reach the goal accurately. So this is delta rule. So here, for applying the perceptrons with the gradient descent, we are having different types of gradient descents. The first one is batch. So batch of gradient and then this is used for each instance. It will be calculated the error. The individual instance ki error calculate chestadi. Adi batch algorithm use chestadi. Batch gradient descent use chestadi. Ingoti untadi stochastic అని. So what is stochastic? Stochastic is nothing but weights will be adjusted according to the instances or input values. So here in batch gradient descent, if we are calculating the error for individual values, ఇప్పుడు example ఏంటి అంటే 10,000 instances ఉన్నాయి మన దగ్గర. ఆ 10,000 instances మనము calculate చేసేటప్పుడు sometimes it misfires. So this is the disadvantage in batch gradient descent. But in case of stochastic, it is not. So gradient descent ki manchi example ఏంటి అంటే when we are feeding the small children. చిన్న పిల్లల్ని ఫీడ్ చేసేటప్పుడు మనం ఏం చేస్తాము? చిన్నప్పుడు కొంచెం పెడతాము, కొంచెం పెద్దగా అయ్యాక ఇప్పుడు 1 year వరకు కొంచెం పెడతాము, మళ్ళీ 5 years వచ్చేసరికి కొంచెం ఇంక్రీజ్ చేస్తాం ఫుడ్, తర్వాత 10 years వచ్చేసరికి కొంచెం ఇంక్రీజ్. నెక్స్ట్ అకార్డింగ్ టు దెమ్ దే విల్ మేనేజ్. So this is gradient descent. Gradient descent is nothing but according to the error rate we will improve the weights. We will change the weights for the input values. So that is gradient descent. Okay. So for finding the error rate in the network, we will be using gradient descent and delta rule. So that is delta Wi. Okay. With respect to E is nothing but your error rate. So this is your perceptron. Any doubts regarding anything, guys? Next, I'm asking to you any doubts regarding anything. Yeah, give me 5 minutes. I'll discuss K-means algorithm also. So that is your fourth experiment in your lab.
Ma'am, your audio is cutting it.
Yeah, guys. Can you hear me?
Yes, ma'am.
So your fourth experiment, your lab is related to k-means algorithm. So k-means algorithm is unsupervised learning algorithm.
Ma'am, your voice is cutting a lot.
Voice is not clear.
Yes, ma'am. In between, sometimes it cuts off.
You're getting disturbance.
Yes, ma'am.
Yeah. Okay. Okay. Now in the class also it was like that only, or
Ma'am, we
now
were giving exam, no, in the morning. I was not present in class.
now
Now it's okay, ma'am.
so your fourth experiment is related to k-means clustering algorithm. Okay. So k-means is an unsupervised learning algorithm. It is used to solve the clustering problems in machine learning, data science, etc. So we will learn what is k-means clustering algorithm, how does it work, and what are the implementation of the k-means here. So first of all, k-means algorithm is nothing but it is unsupervised learning algorithm. That is nothing but I have told you, you don't have any class label. You don't know the output here. So whatever the data which is present, only the data is given to the system, and the system will evaluate the output. Okay. So this is nothing but unsupervised. But in case of supervised learning algorithm, there we know what is input value, what is the output value. The target function, class label, and detail there is one. So if you take yourselves in your class, if you pick any student, so till now, what is the result of that particular student? We know. Okay, so this data is given to the system, and it will evaluate and uses the output. That is supervised. But in case of unsupervised, we don't know the output. We just know what are the details. To that details, we should get the output here. Okay, so k-means is unsupervised learning algorithm here. So which will group the unlabeled data set into different clusters. Okay. So what will happen? It will cluster the data. How many clusters we want? Those many clusters it will be grouped. And it defines the number of predefined clusters that needed to be created in the process. If you want to group the data into two clusters, that is something but k is equal to 2. K is the clustering group of the data here. So in case of we are having 100 instances. If you are having 100 instances, so those 100 instances I want to group into two. How? 50, 50. Okay. Otherwise, take your class. In your class, you are having 73 students. Have to group into two, boys and girls. That is k is equal to 2. So in that way, we have to mention the k value. How many clusters we want to group. So that is k. If you want to use k is equal to 2, that is 2 clusters. K is equal to 3, that is 3 clusters. So likewise. So it is an iterative algorithm that divides the unlabeled data into k different clusters in such a way that each data set belongs to only one group that has similar properties. So if you see here, K means clustering algorithm mainly performs two tasks. What is the first task here? It determines the best value for K center points or centroids by an iterative process, and it assigns each data point to its closest K center. Those points which are near to the particular K center creates a cluster. So ఏం చేస్తుంది data అంతా plot చేసుకున్నాము. So if you see here on the screen, you are having two diagrams, two graphs in it. So on the left hand side graph, there are different types of data which has been plotted in the graph. Now what we have to do, we have to group this data. So I want to group it into 3 clusters. So what I'm doing, I'm using k-means. Before k-means, it looks like that. After applying k-means, it has been grouped into 3 parts. Black as one group, green as one group, blue as one group. Okay. So here how it works. Select the number k to decide the number of clusters. K group అంటే మీరు డేటాని ఎన్ని క్లస్టర్స్ గా గ్రూప్ చేయాలనుకుంటున్నారు ఫస్ట్ డిసైడ్. సెలెక్ట్ ర్యాండమ్ k పాయింట్స్ ఆర్ సెంట్రాయిడ్స్. ర్యాండమ్ గా పాయింట్స్ సెలెక్ట్ చేసుకోండి, సెంట్రాయిడ్స్ ని సెలెక్ట్ చేసుకోండి. అసైన్ ఈచ్ డేటా పాయింట్ టు దేర్ క్లోజెస్ట్ సెంట్రాయిడ్. ఒక్కొక్క పాయింట్ ని ఆ సెంట్రాయిడ్ కి కంపేర్ చేయండి. వెదర్ ఇట్ ఈస్ నియర్, సో గ్రూప్ ఇంటూ దట్ పర్టికులర్ cluster. Otherwise, you can group into another one. So now what you have to do for this, you have to calculate variance and repeat this process. If any reassignment occurs, then go to step 4 and finish the process. So the model is ready. So if you see here, the data is plotted here. I want to group this data into 2 parts. So I have taken 2 centroids here. One is blue and orange. So now what I am doing, I am checking for the nearest values here. So the nearest values, I am finding the distance between all the points to get the nearest values. So I have created one hyperplane. After that, I have taken one more centroid. Again, I have checked 2 other points. So likewise, I have to repeat this process. After repeating this process, at last, you will get this. The data is grouped into 2 parts. Okay. So this I will show you by numerical example. So there is one data set. To this data set, you are applying k-means clustering algorithm. Okay. You are having 2 variables, that is x and y. And how many instances you are having? 6 instances. Now what you have to do? You have to see which particular instance is related to another instance. A row inko row toti combine grouping it. So that we have to check. Okay. So now what we have to do? We have to form this particular data set into 2 clusters. So given k is equal to 2, that is nothing but 2 clusters. Take the 2 clusters, that is k1 and k2. Now initially select the centroids. So your centroids are x value is 185, y value is 72 for the first cluster, x value is 170, y is equal to 56 for second cluster. ఇది ఎట్లా వచ్చింది అంటే your table, from your table నుంచి వెళ్ళి మీరు ర్యాండమ్ గా పిక్ చేసుకోండి. ఏదైనా ఒక రో, ఒక 2 రోలని క్లస్టర్స్ గా గ్రూప్ చేసుకోండి. అవి ఇనిషియల్ గా మీరు అవే 2 క్లస్టర్స్ అనుకోండి. ఓకే. సో హియర్ ఐ యామ్ టేకింగ్ ఫస్ట్ row and second row as 2 clusters. Now find the distance between these 2. You will get the distance as 21.93. Okay. So now what you have to do here is check the particular centroid value with other rows which are there in the data set. Okay. So first మీరు ఏం చేస్తున్నారు, క్యాలిక్యులేట్ ద యూక్లిడియన్ డిస్టెన్స్. యూక్లిడియన్ డిస్టెన్స్ ఎట్లా ఫైండ్ చేస్తున్నారు? ఇప్పుడు 2 k1 k2 కి యూక్లిడియన్ డిస్టెన్స్ ఫైండ్ అవుట్ చేస్తారు. ఓకే. సో క్లస్టర్ 1 ది వాల్యూ 185.185, 72. దిస్ ఇస్ యువర్ ఫస్ట్ రో. నెక్స్ట్ distance from cluster 2. What is your cluster 2? 170, 56. Okay. So what is happening here? Cluster 1 ki always ga danto cheste distance you will be getting 0. But if you do the distance between 1 and 2, K1 and K2 distance కనుక్కుంటే మీకు ఎంత వస్తే 21.93. సో ఇన్ ద సేమ్ వే distance from cluster 1 కి కూడా కనుక్కుంటే 21.93 వస్తుంది. Okay, keep this aside. Now what you have to do here is compare each and every other points which are there in the table. So మీతో ఏమున్నాయి, థర్డ్ రో, ఫోర్త్ రో, ఫిఫ్త్ రో, సిక్స్త్ రో, ఇవన్నిటిని 1, 2 తోటి కంపేర్ చేయాలి. డిస్టెన్స్ కనుక్కొని కంపేర్ చేయాలి. ఓకే, సో నౌ calculate the Euclidean distance for the next data set. Next data set is 168, 60. Okay, so now find the distance from cluster 1. Cluster 1 the మీకు ఏంటి, 185, 72 is your first cluster. Okay, find the distance between 185, 72 and 168, 60. So take the Euclidean distance, then you will get 20.808. Okay, in the same way you have to calculate the distance from cluster 2 also. Cluster 2 find out just 4.472. So now K1 value 185, 72, K2 value 170 plus 168. ఎందుకు మనకి 168/2 is equal to 169. So why we are using this means 20.808 you know 4.472 లో minimum value ఎంత 4.472. Okay, after calculating the distance from 2 clusters to the third row, the value is 1 ని 3 ని Euclidean distance కనుక్కుంటే 20.808, 2 ని 3 ని కనుక్కుంటే 4.47. So comparing these two, the minimum value is for cluster 2. Okay, so 168, 60 అనే value cluster 2 కి బిలాంగ్ అవుతుంది. ఓకే, ఇప్పుడు ఏమైంది, 2 values కంబైన్ అయినాయి. So that particular value has grouped to 170, 56. Okay, so these two pairs has been grouped. అంటే ఇవి రెండు cluster 2 కి వచ్చేసాయి. Now again you have to find the centroid. ఎందుకు centroid? ఎందుకనంటే ఒక న్యూ పాయింట్ వచ్చి క్లస్టర్ లో కలిసింది కాబట్టి centroid కనుక్కోవాలి వల్ల. కాకపోతే ఫస్ట్ క్లస్టర్ ది centroid అంతే ఉంటుంది, సెకండ్ ది మాత్రం చేంజ్ అవుతుంది. సెకండ్ న్యూ centroid ఏమైంది 169, 58. ఎందుకు, ఆ రెండు వాల్యూస్ ని, ఏ రెండు వాల్యూస్ ని, సెకండ్ అండ్ థర్డ్ రో వాల్యూస్ ని యాడ్ చేస్తే మీకు 169, 58 వస్తుంది. సో యువర్ new centroid value is K1 is equal to 185, 72, K2 is equal to 169, 58. Now again what you have to do, you have to find the Euclidean distance for the fourth row. Fourth row value in the 179, 68. Now compare this with the first cluster and compare this with the second cluster. Now what has happened, from these two the value is minimum, cluster 1 value is minimum. So what you have to do, combine this 179, 68 to the first cluster. K1 ki group చేయండి. Okay, so after that you will get this final table. The first row belongs to the first cluster, second row belongs to the second cluster, third row belongs to the second cluster, fourth to 56 belongs to the first cluster. Okay, so for this so if you plot that, that will be like this. So this is your second group, cluster 2. This is your another cluster, that is cluster 1. Cluster 1 lo 4 values ఉన్నాయి, cluster 2 lo 2 values ఉన్నాయి. 2 pairs of values are there in cluster 2, 4 pairs of values are there in cluster 1. So this is k-means algorithm. So that is starting from whatever the data which is there, that will be grouped into different clusters. For that purpose we will be using doubts? Guys, any doubts?
No, ma'am.
So in this way, we will find k-means algorithm to group the data into different clusters. Okay. So to classify the data, we will be using k-means algorithm. So we'll run the code in the next class or lab. Okay. So today I'm having a slight net issue and health issue. So we'll stop here. So any doubts in theory session or in lab, just come forward. All of you execute your programs in home by using Colab also. Okay. Yeah, guys. Anybody? Just send me the attendance. So we will stop here. Pariti, will you send me the attendance?
Yes, ma'am. Just a minute. Everybody stay here. I have to click a screenshot.
So from tomorrow onwards, are you having any IT Bombay exam or anything is there?
Ma'am, today we have.
Yes, you have. Today you have some exam. Tomorrow? Is there any exam tomorrow?
No, ma'am.
So, additional classes.
Okay, ma'am. I do not know, but like for everybody, the exam is there tomorrow.
Okay then. You can leave.
Okay, ma'am.